the mirror equation. Let's consider a concave mirror. Focal point of the mirror, the center of curvature of the mirror. I'm going to place an object beyond C. This distance from the pole to the object is called object distance, XO. Based on the ray diagrams, if you place an object beyond C, you should get an image between C and F. So I'm going to draw the image. Now, the distance from the pole to the image is called image distance, XI. This is the pole, this is the focal point. This distance is the focal length. Distance from pole to the focal point is the focal length. Mirror equation is very simple. The inverse of focal length is equal to the inverse of image distance plus the inverse of object distance. Now if you want to find the image position from this equation, let's rearrange it. 1 by xi equals 1 by f minus 1 by xo. 1 by xi equals cross multiply xo minus f over fxo. To find xi, flip the right hand side. fxo over xo minus f. Now let's talk about magnification. Magnification tells us how big or how small the image is compared to the object. The equation for magnification is m is equal to height to the image over height to the object. Hi is height to the image. Ho is height to the object. Let's say we're getting m equals 2. This means image is double the size of the object. If m equals 3, image is triple the size of the object. If m equals 0.5, image is just half of the object. Another equation for magnification is m equals minus xi over xo. Xi is the image distance, xo is the object distance. So I'm going to call this equation number 1, this one equation number 2. Left hand side is m for equation number 1 and 2. So you can equate the right hand side. Hi over ho equals minus xi over xo. We'll be using this equation when we solve problems. Sign convention. Before using the mirror equation to solve problems, we should follow a set of rules to make sure that our calculations are consistent. This is slightly different than the one we are used to. The right is positive, left is negative. This is just the opposite. Right is negative, left is positive. So anything that you are measuring from the origin to the right hand side is going to be negative. Towards the left, it's positive. Up is positive. Down is negative. Now, where do we place the mirror? Let's say we are placing a concave mirror. The pole of the mirror should be at the origin of the coordinate system. This is the pole. It's at the origin. Let's say this is the focal point, and this is the center of curvature. So this distance from the pole to the focal point is the focal length. We are measuring it towards the left. So the focal length of a concave mirror is positive. What about convex mirror? So let's draw a convex mirror. For a convex mirror, focal point is on the right hand side. So that's a focal point, and that's the center of curvature. So the focal length is the distance from the pole to the focal point. We measure it towards right. So the focal length is going to be negative for a convex mirror. Same for the radius. For a concave mirror, radius of curvature is positive. For a convex mirror, radius of curvature is negative. Focal length of a concave mirror is positive. That of a convex mirror is negative. Now let's say we are placing an object here. That's the object distance from the pole to the object. This distance is XO. This is the front side of the mirror for both convex and concave mirrors. So object distance is always going to be positive. But for the image position, let's say you're getting an image on the same side. In this case, this is the image distance, distance from the pole to the image, xi. If the image is on the left hand side, then xi is going to be positive because left is positive. But if you're placing the object between the focal point and the pole, you're going to get an image behind the mirror for a concave. Yeah. In this case, xi is going to be negative. We measure xi from the pole to the position of the object, position of the image. It is on the right hand side, which is the negative x-axis. So xi is going to be negative. About the height, we always place an object upright. So HO will be positive, height of the object. We're measuring it upwards. So that's positive. If your image is inverted, then HI is negative. Negative. Real images are inverted, so HI is negative. In this case, if you're getting an upright image, an erect image, HI will be positive.